Hello, this is Professor Eckhouse, and I am going to talk to you today about section 2.1, using the language of algebra. Now, this introduction section looks just a little bit different, and I'm going to start doing this for every section, where you can, from OneNote, you can click on these underlined, you can tap on the underlined sections, and that will take you directly to the textbook for that section. So all of the objectives are there, and you can click right on it. So there's even the introduction and the summary. So everything is there. So be sure you're using the book, including the introduction and the summary. The summary has lots of equations and the terms, vocabulary, and all the things you need to know. There's try-it problems in there, lots of try-it problems and videos for every single kind of problem. All right, so you can use those links to go straight there. Okay, so using variables and algebraic symbols, what's the difference between these two? A variable is a letter, even a Greek letter sometimes, that represents a number or a quantity whose value may change. That is why it's called a variable. It comes from the word, right here, it comes from the word vary, to change. Okay, a constant always stays the same. That is what the word constant means. It stays constant, it doesn't change. So it's just a number. Okay, so variables can be like x, y, z, comma, b, c, and they're usually small case. They're not usually capitalized. Capitalized usually stands for some different things, but it can be anything. I mean, it can even be alpha, beta, gamma, things like that. So when you get into higher maths, you'll see that. They are a placeholder. It's a placeholder for an unknown value usually. Unless you're told what the value is or figure out what the value is, it's holding the place of something. And often it's a situation where that number can change. Okay, so at this time you're going this fast, and at this time you're going that fast. So it changes depending on something else. Okay, and a constant, again, is just a number. It stays constant. All right, using the inequality symbol. So first we need to make sure you understand that this symbol right here, it means is equal to or is the same as, okay? And when we see this symbol here, that means it is not equal to. You know, we write the equal sign and put a line through it. That means not equal to. This symbol means less than, okay? And that's how you say it. A is less than B. A is less than B. And however you want to remember that, I always used to remember it, and now I remember it, but I used to remember by the small side is next to the smaller number, and the wide open side, like that, is next to the bigger number. And that's, I think, how it was originally meant to describe things. The next one, A is greater than B. A is greater than B, and if A is less than B, so let's look at this one right here. A is on the number line, then B is over here. A is less than B. Whereas A is greater than B, we would have B here, and A is over to the right. So remember, on the number line, going to the right means it's getting bigger. All right, if you have a line underneath that alligator symbol thing, it means or equal to. So you would say this one, A is less than or equal to B. All right, the next one, A is greater than or equal to B. All right, so it can be any number greater than or equal to B. So that's how the inequality symbols work. All right, so let's translate these from algebra to words. So I'm just going to talk through these. I'm not going to write them all down. My writing is terrible. So we've got 20 is less than or equal to 35. 20 is less than or equal to 35. Okay, that was number one. Number two, we've got 11 is not equal to 15 minus 3. Well, 15 minus 3 is 12. So yeah, 11 is not equal to 12. All right, so I'm going to erase all that mess. Keep going. So 9 is greater than 10 divided by 2. Okay, 9 is greater than 10 divided by 2. 10 divided by 2 really should have parentheses around it. I would prefer to see it like that, but that's what they're trying to say. 9 is greater than 10 divided by 2. So 10 divided by 2 is 5. So yes, 9 is greater than 5. This next one, says x plus 2 is less than 10. So that we'll learn how to solve these, but it just means that some unknown number, some variable, we don't know what it is, plus 2 is going to be less than 10. Less than 10, okay? All right, so there are lots of examples in your book. Right here, I've even got the link in this section right here, 2.1a is where all of that was. Okay, so moving on to grouping symbols in algebra. When we do PEMDAS, which is the thing we're going to talk about in just a second, please excuse my dear Aunt Sally, and it stands for different things, but the first thing there that it stands for is parentheses, parentheses. So there's actually a new way to do this that that a lot of people don't know about, that is a better description for parentheses, because this is technically parentheses right here, but these are also grouping symbols. So really by parentheses, we mean grouping symbols, any grouping symbol. Okay, so all of these different things are grouping symbols. Right, so, and you can have them in any order, but normally the parentheses are on the inside, the brackets come next, and the braces come on the outside. So as you can see in this one here, we've got something in parentheses, and then outside of that, we've got something in brackets, and then outside of that, we've got the braces. Okay, so we'll look at order of operation soon. All right. Oh, so before I go on, some other grouping symbols, just so I don't forget. Also, I'll just say also. You'll see a square root sign or a cube root sign or fourth root sign. That is a grouping symbol. Okay, it's considered a grouping symbol. And also a fraction bar, right? So the fraction bar is a grouping symbol. Okay, so the things you do on top and the things you do on the bottom separately, and then you can work on them together. But you always do what's on top first, or separately from what's on the bottom. All right, let's see. The next thing is expressions and equations. And my question here is, what is the difference between these two boxes of things? And I'm going to start by just comparing one line at a time. So we've got 3 plus 5. We say 3 plus 5, and the phrase is the sum of 3 and 5. Okay, so this is an expression. So I want to make sure that's really clear. These are expressions. Down below, we have equations. Okay, and we've got 3 plus 5 equals 8. The sum of 3 and 5 is equal to 8. What is the difference between those two? Well, the only difference is this equal sign. Notice there is no equal sign in the first box up above. It's just an expression. The ones down below are equations. So an equation has an equal sign. Okay, there's two sides to it. All right, so let's just look at a couple more. N minus 1, the difference of n and 1. N minus 1 equals 14. N minus 1 equals 14 is how you would say that, or the difference of n and 1 is 14. Okay, so there's some more examples there that you can take a look at. But notice all of these down below in the equations have an equal sign. That's where the word equals comes from. Equals and equation both have the same base. All right, so an expression is a number, a variable, or a combination of numbers and variables and operations and symbols. Right? So it's just a bunch of terms. Those are called terms. Okay, so a bunch of terms. An equation is made up of two expressions connected by an equal sign. So it's an expression on each side. Even just a single number is really considered an expression. All right, so we're supposed to determine if each of these is an expression or an equation. So the first one is an equation because it has an equal sign. What about the rest? Pause the video and see if you can come up with an answer for each of those. All right, so hopefully you took a look at those. This one is an expression. The next one is also an expression because it is just a collection of terms with no equal sign. Okay, it's mathematical operations, things like that, but no equal sign. This one has an equal sign, so it is an equation. Okay? All right, so simplify expressions with exponents. We have an exponent here, and that is this part right here. Okay, so then the exponent is on a base. Okay, so there's always a base, some number or a variable, raised to an exponent, some other number. Okay, so this is what it really means is 6 to the third means 6 times 6 times 6, 3 times. So it's repeated multiplication. Okay, so I'll write that down. This is called repeated multiplication, and that's what an exponent is. Talk and write a different word at the same time doesn't always work. All right, repeated multiplication. 6 to the third is 6 times 6 times 6. Two special exponent names is squared, so that would be something like 3 to the 2 power. So that's what the squared is right there. X to the 2 power, 100 to the 2 power, those are all squared. And cubed is to the third power. So we would have 3 to the third power, that's the cubed. X to the third power, 100 to the third power, that's cubed. Okay, so those are the special exponent names. So let's write each expression in exponential form. So what you're going to do is just count. Notice that they're all multiplied together. There's no plus or minus, no division, all multiplied. Make sure, because it might trick you. 1, 2, 3, 4, 5, 6, 7. So this is 16 to the 7th power. Now, because I have 2 digits, I want to make sure it's really clear that I'm raising the whole thing to the 7th. So you might want to use parentheses. Just makes it more clear that it's not just the 6. It's the whole number. You don't always have to do that, but sometimes there's times when it's way more appropriate to use parentheses so you can say which part of this is being raised to a power. All right, so you try the next 3 and then come back and we'll talk about the answers. All right, so hopefully you paused and you've come back and we've got 1, 2, 3, 4, 5, 9, so 9 to the 5th. We've got 1, 2, 3, 4 x's, so x to the 4th. 1, 2, 3, 4, 5, 6, 7, 8. So we've got a to the 8th. Okay, so the index, right? So this is called the exponent, the index, or the power. So I'll use those terms interchangeably. So the index on the a is 8. All right, so write we're going to go the other direction with this. Write each of these in expanded form. So pause the video and give it a try. Okay, so this first one is going to be 8, 6 times. 1, 2, 3, 4, 5, 6. A very big number. You would, on your calculator, have to do that 8 times, but there's a faster way to do it on your calculator. X to the 5th is x times x times x times x times x, multiplied 5 times. All right, so I want to talk about how to do this on your calculator. Hopefully you have a TI. I don't have the top of this on here, but it's an XS. I don't have mine handy, so I can't look. Oh, yes, I do. So this is a TI 30XS. 30XS. Okay, so that's the one that was required for the class, and hopefully this is the one you have. If you don't, you might need to ask me how to use it. So I don't really want you saying 2 times 2 times 2 times 2, right? I would rather you learn how to use the calculator. So you're going to hit the 2 button, raised to button, that's that caret right there. So right here, the caret button, raised to the power of 4, and then just hit enter. So that's how you do that. And when you do that, you should get 16. All right, 5 to the 3rd power, you're going to take 5, caret, and then 3, and then enter. Okay, 5 times 5 is 25, times 5 again is 125. All right, so I would like to ask you to try a problem. So pause the video and try 4 plus 2 times 3 in your head or on the calculator, and what do you get? I'd like you to try it in your head first and see what you get. Check it on your calculator. So pause the video and give that a try. All right, so if you remember PEMDAS, PEMDAS says that we do multiplication and division first. So really this happens first. And sometimes I use parentheses. I add the parentheses to the problem so that I can see the multiplication and division. It stands out to me and I don't forget. So we're going to do the 2 times 3 first. So 2 times 3 is 6. So I miswrote that. That's a plus. Sorry. So the 2 times 3 is 6, and we've still got the 4 plus, so we get 10. So the answer is 10. All right, so this is our PEMDAS. If you have forgotten it, this is probably what you learned in elementary, middle school, hopefully. And if you didn't, you need to talk to me about it probably, but I'll just briefly tell you. PEMDAS stands for first we do any sort of parentheses, brackets, and grouping symbols. Okay, so remember I talked about that above. Then we do exponents. Then we do multiplication and division from left to right, just like you read, left to right. And then we do addition and subtraction again from left to right through the problem. Okay? So first parentheses, then exponents, then multiplication and division together, left to right, then addition and subtraction together, left to right. So what's really important here is this together thing right here. A lot of people think because PEMDAS is written the way it is that multiplication comes before division. That is not true, and it will often give you the wrong answer. All right, a new way to talk about a mnemonic to remember things is, instead of PEMDAS, is to use GEMS. GEMS, G stands for groupings, E stands for exponents again, M stands for multiply, divide, both of them left to right, and S stands for subtract, add, left to right. So that is a different way of looking at it, and you can use whichever one you want, whatever helps you to remember. All right, the rest of this is mostly examples. So what I would recommend is pause the video and do the problem, and then come back and watch me do it and see if you got it right. All right, so go ahead and pause. Hopefully you are going to try that, because I think it'll work a lot better for you. Okay, so all I see here is multiplication and division. So we're just going to go left to right in these. There's no addition, subtraction, exponents, nothing else. Okay, so the first thing we do, I'm going to write these down below. 18 divided by 9 times 2. So 18 divided by 9 is 2 times 2. Okay, so we bring down the 2. 2 times 2, now we do these two and we get 4. All right, number 2. 18 times 9 divided by 2. So first we have to do the 18 times 9. All right, so 18 times 9 is 162. 162. And then we're going to bring this down with the division sign. So divided by 2. So 162 divided by 2, we'll do those two, is 81. Okay, very different number depending on the order that you do the addition, the multiplication and the division. Multiplication and division. Okay, so be careful what order you do things in. Always go left to right with multiplication and division. All right, here's another one. So remember PEMDAS, we're going to do things in parentheses first. So we're going to do this 5 minus 2 is 3 right there. Okay, so we've got 3. All right, now we've got 18 divided by 6 plus 4 times 3. 5 minus 2 is 3. All right, so now I need to look across this and see where's all my, there's no exponents, so now I'm going to skip to multiplication and division. So I see multiplication and division here, and I see it here. So what I'm going to do is I'm going to use, it doesn't matter what shape your brackets are. You can use any shape, it doesn't matter. So 18 divided by 6 then is 3, and then I've got the plus symbol in between, and 4 times 3 is 12. So 3 plus 12 is 15. Okay. All right, so a couple more examples. So again, we can use GEMS if we want to. I'll do that one just to be different. We're going to do the groupings first. Okay, so all groupings first. So I've got 4 minus 2 is 2. So I'm going to go ahead and rewrite this. 4 plus, now, because this is just an individual number, 2 to the third, I can go ahead and work it so that I have a little less to write later. I can write 2 to the third equals 8. Right, plus 3 times 6 minus 3 times, we decided 4 minus 2 is 2. All right, so now we need to continue working from the inside. So I've got this 3 times 2 is what I'm going to do next. And I've got 5 plus 8 plus 3 times 6 minus 6. 6 minus 6. Oh, great. So this thing right here is going to be 0. So I've got 5 plus 8 plus 3 times 0. So 3 times 0 is 0, right? So I've got 5 plus 8 plus 0. So I'll take it over here because I'm running out of room. 5 plus 8 plus 0. So 5 plus 8 plus 0 is 13. All right, one more example. No parentheses here, but lots of exponents. So remember GEMS. GEMS says grouping first. There are no groupings. So then we're going to do exponents. Okay? So we've got 2 to the third is 8 plus 3 to the 4. 3 to the 4 is 81 divided by 3 minus 5 squared is 25. All right, now I've got plus, divide, and minus. So the division is the multiplication division. That happens next, right there, multiplication division. All right, so I've got to say 8 plus, and you can put parentheses around it if you want to so it jumps out at you. 81 divided by 3 is 27 minus 25. Now we're going to go left to right. So 8 plus 27 is 35. And we've got to carry this down, right? Minus 25. 35 minus 25 is 10. All right? So that is it as the mower gets closer outside the window. Thanks for watching.